The past several days in class, we've been talking about what to do when you have a right triangle and they are asking you to find a side of the triangle. And so some things that we've talked about is you could use Pythagorean theorem. If you have a right triangle and you're given two sides of the right triangle, then you could just use that formula to find the third side. You just plug it in. We also talked about 45, 45, 90 triangles and 30, 60, 90 triangles. And we talked about their special properties that you can use with those types of triangles to find the sides of those triangles. And so today is kind of a continuation of the right triangle theme. Today we're going to talk about, well, what happens if you have a right triangle and you're given information and you're asked to find a side or an angle and none of the other stuff works. Well, something else that you could try is you can try what's called right triangle trigonometry. Okay, and so that's what we're going to spend the next several days actually in this class talking about. Okay, so the first thing that you need to make sure you remember is the trig that we're about to talk about will only work for right triangles. Okay, so whenever you're looking at a problem and you're trying to figure out if you can use what we're going to talk about, you've got to check to see if it's a right triangle first. All right, and so to be able to use trigonometry to find a side or an angle of a right triangle, you actually have to be able to do a couple things first. So that's what we're going to spend today talking about is what is some of the prep work, I guess, to be able to use right triangle trig, all right? So the first thing that you have to be able to do to use this is you have to be able to label the sides of your right triangle. And then you have to be able to set up what is called a trigonometric ratio. And so those are the two things that we will work on today. All right. So we're going to start with how to label the sides of the right triangle. All right. So I'm going to draw a right triangle here. And then we're going to talk about the three different sides that you can have. All right. So this is supposed to be just a general right triangle, nothing real special about it other than the fact that it's a right triangle. All right. So to be able to start these problems, you're going to be looking from or going from an angle in your triangle. Okay. And so you first have to figure out which angle you are looking from. And this will be something that we come back to as we start actually working problems. But I want you to go ahead and be aware that that's something that you're going to have to look at first. All right. So whenever you figure out the angle that you're going from, you're going to actually act like you are standing at that angle looking at the triangle. And I usually, just for myself, I usually put a dot or a little arch in the angle so that I can remember which angle I was looking from, okay? And something that you need to keep in mind for these problems is with this trig stuff, you will never, ever, 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 ever stand at or look from the 90-degree angle, okay? And so wherever that right angle is, you'll never stand there, all right? And so in this triangle, I would either be going from this angle right here, so that little corner, or this angle right here. Now, as to which one, for the purpose of what we're doing today, they'll usually tell you which angle to stand from. But when we actually start working through the problems, you'll have to actually figure that out yourself, which we will cross that bridge when we get there. All right. And so let's say, just for the purpose of this problem, that we're standing at this angle right here. All right. So you could either put a little dot in the corner right there to show that you're kind of standing there looking at your triangle, or you might see in some of these problems, they may put an actual arch there. And so either way, just as long as you know which angle you're standing at, okay? After that, now we can actually start labeling the sides, okay? So to label them, there's going to be three different sides that you'll label. You're going to have the hypotenuse, you're going to have the opposite side, and then you're going to have the adjacent side, all right? So the hypotenuse we've talked about already. The hypotenuse is the side of your triangle that is opposite of your 90-degree angle. And so that's usually one that's pretty easy to label. So the side opposite of the 90-degree angle. All right. And so when I'm looking at my triangle, there's my 90-degree angle. So what side is opposite of that? So it's kind of like the side that this angle opens up to. So notice this right here is the side that this angle opens up to. Another way of thinking about it is it's the side of your triangle that this angle doesn't touch. Because notice this angle right here touches this side and that side. This is the side that it doesn't touch. So this one right here would be your hypotenuse. So let's label that. Okay. And then the opposite side in your triangle, this is the reason why you have to know which angle you're standing at, is actually opposite of wherever the angle is. So like if you're standing right here, you're looking for the side that's opposite of that angle. Okay. So this opposite side is opposite of where you are standing. Okay, or you can think of it as it's opposite of where your angle is. Okay, and so if I look at this angle, the side that it opens up to or the side that it does not touch would be this side right here. So this side right here would be my opposite side. Okay. And then the adjacent side, that's the one that is a little bit trickier for most people. So usually I just kind of use process of elimination and I find my other two sides first. So if you already know what these sides are, then you can kind of look at your triangle and know which one's the adjacent side. But the adjacent side is the one that is beside where you're standing. So adjacent, a lot of people think associate with the word beside. So it's beside the angle you're standing at, beside where you are standing. But it's not the hypotenuse. Okay, so the side that's beside where you're standing, but not the hypotenuse, would be this side right here. So this side would be your adjacent side. Okay, so what we're going to do to begin with is just practice with a couple problems labeling the sides, and then we'll go on to talk about how to set up a trigonometric ratio. Okay, and so let's look at these two examples I have right here and let's practice labeling my sides. All right, so for number one, it says label the sides from angle A. So like I said, with these problems, a lot of times they're going to tell you which angle to go from. And so in this problem, they're telling you to go from angle A. And so look at your triangle. Notice it is a right triangle because it has a right angle there. And then I see angle A is right there. So again, you can either put a little dot where angle A is, or some people like to put a little arch in the actual angle part. Either way is fine. And then we're going to just practice labeling our sides, all right? So I usually start with a hypotenuse. It's the one across from that 90-degree angle. And so there's my 90-degree angle. Which side is opposite of that angle? Well, the side that does not touch that angle would be where the 13 is. So the 13, the side labeled with the 13, would be your hypotenuse. And usually we'll just label it with an H so that we don't waste time writing the whole word. So there's my hypotenuse. So then the next side would be the opposite side. The opposite side is opposite of where you are standing. So it's opposite of the angle that you're going from. And so if this is where we're standing looking at our triangle, which side would be opposite of that? Well, the side that this opens up to, or the side that this angle does not touch, would be this side right here. So the side labeled with the 5 would be my opposite. So I'm going to put an O for opposite. And then by process of elimination, again, we know which side's the adjacent side, but the adjacent side is going to be next to where you're standing. Notice this side is next to where you're standing, but it's not the hypotenuse. So this would be our adjacent side, which we will label with an A. And so we have now labeled the sides of that triangle. All right, so let's practice this one more time, and then we'll move on to actually learning the trig. All right, so label the sides from the indicated angle below. So notice with this one, they've actually shown us by putting a little arch in the angle, which angle to go from. All right, and so you've got your right triangle, okay? Remember, this stuff only works for right triangles, so make sure it is a right triangle. And we're going to label it, all right? So start with the hypotenuse. Remember, the hypotenuse is the side opposite of the 90-degree angle. So the side that's opposite of my 90 would be right here, so that's my hypotenuse. The side that is opposite of where you're standing. So this would be technically where I'm standing. Which side is opposite of this angle? Well, the side that this does not touch would be this side right here. So that's my opposite. And then the adjacent is beside where I'm standing, but it's not the hypotenuse. So this side right here would be my adjacent side. And so that's pretty much all there is to labeling the sides. All right. Now we get to actually work on setting up and learning the trig. All right. So let's move on to the fun stuff. All right. So to set up a trig ratio, and what this actually is actually practicing setting up problems so that we can solve them. All right. So tomorrow we'll work on solving problems, but today we're just working on setting them up. Okay. And so whenever we're setting up a trig ratio, first thing I want you to realize is what the word ratio means. All right. Ratio is really, if you think about it, kind of a fancy word for a fraction. And so anytime you see the word ratio, really it's just a fraction. The reason why they call it something different is because usually they'll use the word ratio whenever they are comparing two things. So they do write it a little bit differently. Usually they'll put like a number and then a colon and then the other number. But in these problems, we're going to be actually writing it as a fraction. Okay. So before we can actually start setting up the problems, we have to learn the trigonometry, or sometimes you'll hear me call it, or some people will call it trig for short. Okay. And so this, what we are about to write down, is something that you will have to memorize. Okay. So I'm going to try to give you some ways to remember it, but let's learn the trigonometry. All right. So this we will use in the next couple of days to help us find the sides and angles of right triangles. All right. So the first thing that you have to know in terms of trigonometry is, what does this deal with? Well, it deals with the functions sine, cosine, and tangent. All right. So anytime you see these functions, that is trigonometry, and there's more to it, but that is trigonometry. All right. And so the things that you have to remember is, how do these functions relate to the sides of the right triangle? All right. So this is the part you have to memorize. So first off, when you set up the problem, we usually shorten the words. All right. So the sine, when you take the sine of the angle that you are standing at, so the symbol for angle is a little, some people will just put the little angle thing. Sometimes you'll see them put a little arch in it, okay? But this means angle. So when you take the sine of the angle that you were standing at, or that you're dealing from, it'll actually equal the opposite side of that angle, so whichever side was opposite of it, over the hypotenuse in that right triangle. All right, so the sine of an angle is equal to the opposite side of that angle over the hypotenuse of that right triangle. All right, the cosine, so what you have to memorize about the cosine is, if you take the cosine of that angle that you're standing at, it's actually equal to the adjacent side over the hypotenuse. And what we're dealing with here is the lengths of those sides. So you take the length of the adjacent side over the length of the hypotenuse. And then the last thing that you have to memorize in terms of this trig stuff with the right triangle stuff is what do you do whenever you have the tangent of an angle? Well, when you take the tangent of the angle that you're standing at, it's actually equal to the opposite side of that angle over the adjacent side. Okay, so this is the stuff you have to memorize, all right? And a lot of times people don't always just memorize it flat out like that. A lot of times they'll remember it with like an acronym or a sentence. And so we're going to put to the side some ways to remember it, all right? So one way that a lot of people remember this trig stuff is by using an acronym, okay? And the acronym kind of sounds like a crazy sounding word, but it may help you to be able to find a way to kind of get this in your head. All right. So the acronym that most people remember this by is by memorizing the word so, ka, toa. All right. So say it to yourself. So, ka, toa. So, ka, toa. And so if you want to remember it that way, it'll actually help you remember what goes with what, okay? And so you kind of group it into threes. So notice, look at this and then look at that and kind of try to figure out why does that help you remember, okay? Well, if you look, the S is the sine, the O opposite, H hypotenuse. So this part helps you to remember it, but you do have to remember it's the sine of your angle, so don't forget that part. But this helps you to remember if you take the sine of your angle, it'll equal, so don't forget the equals in the middle either, the opposite side over the hypotenuse, okay? And so then from there, you can kind of see where the other stuff comes from as well. So this would be that the cosine of the angle equals the adjacent side over the hypotenuse. And then this would help you remember the tangent of the angle is equal to the opposite side over the adjacent side. Okay, so that's the acronym, all right? Now, some other people, if that doesn't work for you, another way that you could remember it is there is a sentence that some people remember. And the sentence that they remember is, oh heck, another hour and I'm going to have to write it down here, of algebra because I'm running out of room. Okay, so how do they remember it that way? Well, this one, you're going to have to remember what the actual functions are. So you'll have to remember the sine, cosine, and tangent. But these will be groups of two in a way. And you'll see what I am doing in a second. So like the sine would go with this, because notice O would mean opposite. H means hypotenuse. So this one goes off of the first letter of these words. So this would help you to remember that sine of your angle is equal to opposite over hypotenuse. This one, the A is for adjacent, the H is for hypotenuse. So this would help you. The next one, you got to remember the cosine goes with that. Cosine would be adjacent over hypotenuse. And then this one, you got O for opposite and A for adjacent. So that'd be opposite over adjacent, which goes with tangent. All right. And now, for all my people that are worried because maybe you want to remember it by the sentence and you're afraid you're going to forget the keys. If you look at the calculator, notice the sine, cosine, and tangent actually go in that order. And so it won't be too hard to remember it if you want to remember it by the sentence. Okay. And so either way you want to remember it, just pick a way and stick with it. That way it'll kind of be drilled in your head. And then you'll be able to do this stuff without too much of an issue. All right. So we are going to actually use this trigonometry. And today, like I said, we're going to just practice setting up the problem. So we're going to be setting up what are called trigonometric ratios. All right. So let's start talking about how do I do that. All right. So how to use the trig to set up the problems. Well, the first thing you're going to do is like what we did a second ago where we practiced labeling the sides. So that's what we did earlier. And then after that, you're going to go from that angle that you're told to go from, and then you just set up the ratios. And so the ratios are actually these fractions right here, okay? And so we're going to practice a couple problems so you can kind of see how that works, all right? So number one, it says find the sine, the cosine, and the tangent of the indicated angle. All right, so we've got our triangle. It's a right triangle, so I know I can use the trig for it. And for part A, it says we want to go from angle Z. So like I said a second ago, whichever angle they're wanting you to go from, you can either put a little dot, you could put a little arch in it, whichever way you want to do it. And you're going to act like you're standing there looking at this triangle, all right? So the first thing that you're going to do when you have to set up the trig ratios is you label the sides, just like what we did before. So remember, the first side we label is usually the hypotenuse. So it's the one across from that 90-degree angle. So the angle that is across from is the 15. So this would be our hypotenuse. We'll label it with an H. And then the side that's opposite is the side that's opposite of where you're standing. So if you look at where we're standing, looking at this triangle, the side that would be opposite of it would be that 9 right there. All right. And remember, it's the angle, or excuse me, it's the side of your triangle that does not touch your angle. All right. And then the one that's beside your angle but is not your hypotenuse, so that would be this one, would be your adjacent. All right. So that's the first step. Label the sides. After that, you are going to use this that you had to memorize to set up the ratios, all right? So with this one, it's actually wanting us to set up the sine, cosine, and the tangent. It's wanting us to do all of them, all right? And so we're going to do one at a time, all right? So if we're going to do the sine, we're going to go up here and we're going to look. The sine of the angle will equal the opposite side over the hypotenuse. All right. So if I'm doing the sine, I'm going to write sine. And a lot of people will want to call this sin. Make sure that you don't make that mistake. It's actually pronounced sine. Okay. So the sine of your angle, so the angle would be whichever angle you're standing at. So the angle that we're standing at is Z. So we do sine of Z, of angle Z, equals, so sine of your angle equals, and then we just have to figure out what is the opposite side, and then we put it over the hypotenuse. So for this one, the side that's opposite of angle Z would be the 9. So it'd be 9 over, and then the hypotenuse would be 15. Okay, so now with this, some problems will have you leave it like that, but for our problems, I actually want you to reduce it. So if this reduces, then I would prefer you to reduce it. So with this one, a number that goes into both 9 and 15 is 3. And so you would actually reduce it. So 9 over 15 would reduce it, 3 goes into 9 3 times, and then 3 goes into 15 5 times. All right. So if you need to kind of remember what that was, you can write it to the side. All right. So that is the sine ratio for that triangle. All right. So then what if we're going to do the cosine of that angle? All right. So go back up here. The cosine of Z of the angle is equal to the adjacent side over the hypotenuse. All right. So when we do the cosine, we just have to take the adjacent side. So let's see, the side that was adjacent was 12 over the hypotenuse is 15. And so that would be 12 over 15. And that will reduce as well because 3 will go into both of those. And so I'll just write it to the side. So 3 goes into 12 4 times, and 3 goes into 15 5 times. So that is the cosine ratio. All right. So then the tangent. Tangent of angle Z, if we go up here to this part, it's equal to the opposite over the adjacent. So the opposite side would be 9 over the adjacent side would be 12. Okay, and then again, that reduces as well. So 3 goes into both of them. So 3 into 9 goes 3 times. 3 into 12 goes 4 times. So that is the cosine, or excuse me, the tangent ratio. All right, so now what happens if we have to go from a different angle? Well, that means that we're no longer standing where this was, all right? And so what happens, what changes if we change where we're standing at? So I'm going to actually draw a separate picture, and I'm actually going to draw it somewhere else so that I have room to put my answer. So I'm going to draw it just above this problem here. Just going to copy my triangle down. Don't judge my drawing. I'm the greatest artist ever, I know. All right, so let's say that we have to now go from X. Well, that means we're standing here. So think about what would change if we change where we're standing. Well, notice the hypotenuse will still be across from that 90. So the hypotenuse won't change. But the side that's opposite of us is now this side right here, the 12. And then the adjacent side will be the 9 now. All right. So my little ratios will be different. All right. So let's go from X now. So if we go the sine of X, well, remember, sine is the opposite side over the hypotenuse. All right. So the opposite side is 12 over the hypotenuse is 15. All right, and then that reduces. So 3 into 12 is 4, 3 into 15 is 5. So cosine of that angle, cosine is adjacent over hypotenuse. So the cosine would be, okay, the adjacent is 9 over the hypotenuse is 15. All right, and then that reduces. 3 goes into both of them. So it'd be 3/5 after we reduce it. And then the tangent is opposite over adjacent. So the opposite side is 12 over the adjacent side is 9. So it'd be 12 over 9, which reduces to 4 over 3. All right. So I did want you to notice when you change the angle that you're standing at, it does change the fractions or the ratios that we set up. Okay. So pay attention to which angle they're telling you to go from. All right. So let's do a couple more just to practice setting up the problems a little bit more. And then I will let you work. All right. So with this one, it says find the sine, the cosine, and the tangent of theta. So again, we're just practicing setting up the problem, setting up the trigonometric ratios. All right. So if we're going from this, and I know that's a funky symbol, that's a Greek symbol, but it's called theta, and a lot of times they use that to represent an angle. So think of it like an X or something like that. No biggie. All right. So that means that they're wanting you to stand at that angle. All right. So again, you can put your dot or you can put your little arch there. And then again, to begin with, we have to label the sides. All right. So the hypotenuse is across from the 90-degree angle. So this would be your hypotenuse. The opposite side is opposite of where you're standing. And then the adjacent side is the one beside you, but not the hypotenuse. All right. And so if we're setting up all three trig ratios, it's the sine of your angle. So sine of theta equals, well, remember your trig. So you could think about this word, SOHCAHTOA. Sine is opposite over hypotenuse. So go back down here. Sine, let's see, the opposite side would be 15 over the hypotenuse would be 25. All right. And then that does reduce. 5 goes into both of those. It goes into 15 3 times, and it goes into 25 5 times. So the ratio would be 3 over 5. The cosine of theta, well, go back up here. Remember that part. Cosine is adjacent over hypotenuse. So when I do adjacent over hypotenuse, it'd be the adjacent is 20, the hypotenuse is 25, so it'd be 20 over 25. And then that will reduce 2 because 5 goes into both of those, so it'd reduce to 4 over 5. And then the tangent, last one here, tangent would be opposite over adjacent. So tangent of theta the opposite side over the adjacent side, so that'd be 15 over 20, which reduces, because 5 goes into both of those as well, and be 3 over 4. All right, so those are the trig ratios, the trig fractions for the sine, cosine, and tangent. All right, so the last type of problem I wanted to show you is sometimes instead of them asking you to set up all 3 functions or all 3 ratios, they might just ask for one. So like for number 3, it says find the sine of theta. Okay, so they really just want you to take, remember sine, so, it's the so part of your word, and so katoa. Sine is opposite over hypotenuse. So you really just have to set up that fraction, all right? So if we're standing at theta right here, all right, well, what is my opposite side? Well, go ahead and label your sides. The opposite of the 90 is the hypotenuse, so this is hypotenuse. The opposite of your angle is your opposite, and then the adjacent is the one left over, or the one that's beside you but not the hypotenuse. And so we're just looking for what is the opposite and the hypotenuse. So the opposite is 3, all right, so I know that. So it'd be 3 over what? Oh no, we don't know the hypotenuse. Well, we can find it, because if we have 2 sides of a right triangle and we're trying to find the third one, there's a handy dandy theorem called Pythagorean theorem that we can use to find it. So I'm going to use that to find it. So remember, these are your legs. So my legs are 3 and 4. So it'd be 3 squared plus 4 squared equals c squared. And then I just simplify. So 3 squared is 9 plus 4 squared is 16. Bring down my c squared. And then when I add them, I get 25. And then to get rid of the square, I have to square root. And when I square root, C would be 5. So this opposite side would be 5. Okay. And so, or excuse me, hypotenuse would be 5. And so when I set up my ratio, it'd be 3 over 5. So that is the sine ratio according to that angle. All right. So hopefully this helps. Let me know if you have questions. Have a great day.